Hello, today we're going to talk about the functionalization of carbon nanotubes. So you may be thinking, what is a carbon nanotube? Well, let's first talk about carbon. Carbon is an element, but it has various allotropes or physical forms it can take on. Popular examples are graphite, which helps to make pencil lead, and diamonds, which are very expensive. Carbon nanotubes are another allotrope of carbon. While there are single and multi-walled carbon nanotubes, this video will focus specifically on single-walled carbon nanotubes. Okay, but what about the nano part? Well, something at the nanoscale is a billionth of a meter. To put that in perspective, if you compared an object the diameter of a nanometer to a meter, it would be like comparing a soccer ball to the size of the earth. That's really small. So when we talk about carbon nanotubes, these are structures that are so small that they cannot be seen with a magnifying glass or even a microscope. These structures are formed at the atomic level. Carbon nanotubes have a graphitic shape, which means they form patterns of 6 carbons covalently bonded in hexagonal rings that are rolled up in a repeated tube-like pattern. These hexagonal patterns can be arranged in 3 general orientations: armchair, which gives a flat or horizontal direction in the design, zigzag, which gives a vertical direction in the design, and chiral, which gives an angle direction in design. Single-walled carbon nanotubes can range from 0.4 to 2 nanometers in diameter across, but span hundreds of micrometers in length. You can think of this as having a pipe that is 1 meter across in width, but it spans in length from Houston to San Antonio, or we could say San Antonio to Houston. Single-walled carbon nanotubes have fascinating characteristics. They have low density, yet have high tensile strength and elasticity, making them 100 times stronger than steel at the same diameter and 5 to 6 times stronger than Kevlar. Carbon nanotubes also have great electrical, thermal, and optical properties. Functionalization means adding specific chemical groups to the carbon nanotube, just like you add a certain attachment to a power tool in order to do a specific task. This allows carbon nanotubes to be used for applications such as biosensors, aircraft structures, and wastewater treatment. One of the popular ways of functionalizing a carbon nanotube is by using single-stranded DNA. Single-stranded DNA can bond together with a carbon nanotube through a process called guanine functionalization, in which highly energized oxygen molecules called singlet oxygen binds the guanine nucleotides to the carbon nanotube. This allows the carbon nanotubes to be more suitable for biological applications. One of the tools scientists and engineers use to analyze this process is through photospectroscopy. Through this process, specific wavelengths of light can be emitted to energize the carbon nanotube. The valence electrons of the carbon nanotube can be excited to a higher energy level. Once that energy is released and the electrons return back to its ground state, the nanotubes release the energy as infrared radiation, which has a longer wavelength than regular light. When this happens, the nanotubes give off a certain emission that can be read by tools that measure nanotube light absorption, emission, or even measure the degree of molecular movement due to interaction with light, which is called Raman spectroscopy, all of which give details on the molecular structure and the degree of functionalization of the carbon nanotubes. The benefit of functionalizing carbon nanotubes with DNA is the promising uses it can have for medical purposes, such as drug delivery systems, and cancer treatment. So, this is just a little snippet of the functionalization of carbon nanotubes. I hope you enjoyed the show.